Let's say the figure is something like this one. And this is point P, A, B, and let's say Q. So here we can say the first thing that PA into PB is always equal to PQ square. And the second important thing here is, for example, if this is the center of the circle, or I need to find out what is the measurement of angle P. So angle P here is again nothing but half of measurement of arc AQ minus measurement of arc BQ. Now again I need to take the central angle. It means angle subtended by arc AQ at the center. If this is the center, so angle subtended by this particular arc at the center. Let's say this is theta 1, and angle subtended by this arc BQ at the center, this is theta 2. So here we can say that the angle P is nothing but that is equal to half of theta 1 minus theta 2. Now, moving forward here, let's discuss the tangents, that is direct common tangent and the transverse common tangent. How to find out the length of direct and the transverse common tangent. For example, if I say, let's say there are two circles. So this particular length is known as the direct tangent. This tangent is direct tangent. And how to find out the length of this tangent? Let's say this length is denoted by LD. Length of direct common tangent here. Now, if I say this is the radius R1 and this is the radius R2. Join these two centers. This is O and O dash. Let's say the distance between these two centers is nothing but which is D. Now this angle is 90 degree and this angle is also 90 degree because the tangent always make an angle of 90 degree. So if you draw a line from here which is parallel to the length of direct common tangent like this one. So can I say if this is R1, this is also R1, these R1 and R1. So this length is R1, so it means this particular length from here to here which is R2 minus R1. So this length is R2 minus R1 and this angle is 90 degree and this length is nothing but LD. So now can I say that in the triangle, this particular triangle, length of direct common tangent is under root of, so from here we will get the value that length of direct common tangent is nothing but under root of D square minus R2 minus R1 whole square. And this is one of the very important theorem. Now, so this is regarding the direct common tangent. Let's move to the transverse common tangent. For example, if I say these are two circles, the radius of this circle is R1 and the radius of this circle is R2. And if I say, let's say this is a transverse common tangent. So how we can find out here radius? Let's say if this is the center of this circle and this is radius R1 and this is the center of circle, this radius is R2. And if I join their centers, and this particular length is known as the LT, transverse common tangent. This particular tangent is the transverse common tangent. And remember that the length of the transverse common tangent is nothing but under root of D square minus R1 plus R2 whole square. We can prove it in the similar fashion the way we had proved the earlier one in case of the direct common tangent. So these are the certain important theorems related with the circles here. And the last thing, that is the funda of the cyclic quadrilateral. Now what happened in case of cyclic quadrilateral? cyclic quadrilateral is nothing but a quadrilateral drawn inside a circle. So if this is A, B, C, D. So if I say the length is, this angle is A, this angle is B, this angle is C, and this angle is D. So sum of opposite angles of a cyclic quadrilateral are always 180 degree. So here we can say that the value of A plus C is equal to B plus D, which is equal to 180 degree. Now, also one more important thing, that the area of the cyclic quadrilateral is always S minus A into S minus B into S minus C into S minus D, where S is the semi-perimeter of the cyclic quadrilateral. Now we'll take a couple of examples based on the circles here. Now, for example, if I say this is a circle and this is a circle and this is a square, and there is a rectangle at one of the corner which is touching the circle at this particular point. Let's say this is 10 centimeter and this is 20 centimeter, and we are supposed to find out what is the radius of this circle. Now just say how we can find out the radius of this circle. If I say this is the center of the circle, let's say O. So this angle is 90 degree because this line acts as a tangent here. So this is radius R. Similarly, this is radius R. And we can also say that this is also radius, which is R. Now the important thing is, what is this particular length? Now can I say if this is 10, so this length is also 10 from here to here. So if this is 10, so this length is nothing but this is R minus 10. So write down this is R minus 10. Okay. Similarly, if this length is, this is 20, so minus R minus 20 here. Now, if this length is 10, so can I say this entire length is R, this is 10, so this length is also 10. So if this length is 10, so this length from here to here is nothing but R minus 10. So write down this length as nothing but R minus 10 from here to here. Now, can I say that this is nothing but a right angle triangle? So in the right angle triangle, apply the Pythagoras theorem. So from here we get the value that R minus 10 whole square plus R minus 20 whole square is equal to R square. And now on solving this, you can easily find out what is the value of R here. Now, let's take a couple of more examples. Let's say this angle is 90 degree. And if I draw a smaller circle here. Okay, and it has been given that the radius of the bigger circle. Radius of bigger circle is 2 centimeter. So I need to find out what is the radius of a smaller one. Now let's say how we can find out. Now always remember one thing. Since if for any circle, if I say like this way, if this angle is 90 degree, so can I say if this is the radius R and this is the radius R, this angle is 90 degree, this angle is 90 degree also, because these are two tangents, and this angle is also 90 degree, so this angle has to be 90 degree. So this particular length is nothing but this is R, so this is also R, because these two lengths are equal, now it has become a square. So this is R, so this particular length is nothing but this is R root 2. Now apply the same funda here. Now, if I take the radius of the smaller circle as R, let's say for a moment, R. So this is also R. So this particular length I am talking about, this particular length is nothing but R root 2. And now from here